Here's an experiment that can be used to test for the physical and chemical properties of common household chemicals. What I have here is a sheet of paper that I've made up in a table form, and we can lay a transparency sheet over top of that, and then in each of the squares we can add small amounts of the chemical. So here's some flour. So we'll put flour in each square. So now we have all the chemicals on the grid. We can now take a dropper or a dropping bottle and add a small amount of each solution. So first I add some water. And we see then how the substances behave in the presence of water. You'll notice in the case of flour, the water simply rolls off. In the case of baking powder, we're actually getting some fizzing. In the case of baking soda, the water wets the baking soda. In the case of sugar, the water also wets it and seems to dissolve it, as with the salt solution. Now we'll add a few drops of vinegar to each. And again, you notice the baking powder again fizzes a little bit more vigorously, but the baking soda this time also fizzes. And the others are pretty much the same as what we saw with plain water. Next, we use some iodine solution. This can be obtained from a drugstore, and you can actually dilute it with water so that there's plenty for one class. Again, we add that, but notice how black it becomes when I add it to the flour and also to the baking powder. With the baking soda, it stays essentially the same color. And with the powdered sugar, it also turns a little bit dark. Now, starch turns black in the presence, or a deep blue black, in the presence of iodine. And flour, of course, contains starch. Baking powder also contains a small amount of starch to make it free running, as does powdered sugar. If we'd use granulated sugar, it would not turn black. But this gives us a simple way of doing multiple tests on the chemicals, the household chemicals. You can prepare a laminated copy of this for your class and have students work in groups to actually do the tests. Now, to do the last part, which involves heating, we can make a simple aluminum container. So I take a piece of aluminum foil and just bend it and shape it into a little container. It doesn't have to be fancy at all, and I can then use that to put my powder in for heating. So I put a small amount of powder in each of the aluminum containers. We now use the alcohol burner to heat up each of these little dishes. I can use a clothespin to hold the aluminum container over the flame and then observe what happens as I heat it. So don't heat it too much. This, as you can see, smokes a fair bit and also turns black. Now I've got my baking powder. Again, it smokes a little bit, it turns black at the edges, but certainly not quite as dramatic as the starch. Baking soda. It doesn't appear to be doing very much. There's a bit of smoke coming off it. But there's really no change visible. Powdered sugar. Oh, it melts and bubbles. And then lastly, the salt. Again, no change is observable with the salt. Once students have done all these observations, they can then, what to do is to actually grind them up differently or get them in a different form so that they don't look identical to what they had before, and ask them to identify the unknown or unknowns that you give them. This is a great test for observations, because students have to make careful observations for each of the tests and write them in an appropriate chart. You can make a chart similar to what I showed earlier. Here's a close-up of burning or heating the different compounds up over a flame. This is heating flour. You can see it's turning black and giving off lots of smoke. Here we're heating baking powder. Baking powder is a mixture of sodium bicarbonate, ordinary baking soda, and often tartaric acid, a dry acid, and some flour or starch to keep it free running. Again, you can see that it's giving off lots of smoke, turning a little bit black at the edges as the starch burns. Here we're heating baking soda, sodium bicarbonate. And actually you can't see what's happening, but sodium bicarbonate actually decomposes on heating. And that's why we can use sodium bicarbonate, baking soda, as a source of carbon dioxide to put out fires when it's heated. So there's no visible change here. This is the heating of powdered sugar. Again, it gives off some smoke. You can also see it starting to caramelize as the sugar breaks down, turning brown and foaming. Of salt, just some regular table salt. As we heat that in our aluminum dish, you can see that it's jumping around a little bit. Most likely due to a small amount of moisture that's in the salt and breaking the crystals up as the heated water vapor escapes. Otherwise, there's really no visible change when salt is heated.